Hello guys, good afternoon or good morning or good evening, whenever you watching this video. Right. So this is chapter number 4, the reciprocal lattice. Chapter number 4. Betul ke? Yeah, chapter number 4, reciprocal lattice. So we have four key topics. For this chapter, we have the crystal lattice fundamentals, diffraction and Bragg's law, then Fourier analysis, and Brillouin zone. It's up to you how to pronounce it. Sometimes some of my students pronounce it as brilliant. Doesn't matter. Brillouin. I think the most appropriate way to pronounce this is actually Brillouin. Brillouin zone. It's the name of a person. I can't remember his full name, but it's we call it as Brillouin zone. Okay, so we need to take a look one by one the gist of this topic. So by the end of this lecture, I want you not only to remember the formulas, but also to understand why reciprocal lattice is such a powerful tool in solid state physics, especially for BSP students. So this is the outcome for this topic. By the end of this chapter, there are 3 main things that you should be able to do. The first one, you should be able to describe the crystal lattices. What does it mean by crystal? So the opposite of crystal is the amorphous. And what does it mean by the lattices? The primitive cells. We have cells of crystals. Some of it are primitive, some are not. What are the differences? And the diffraction concept, the X-ray diffraction concepts. The second, you should be able to apply Bragg's law and reciprocal lattice vectors to solve basic problems. Of course, you need calculations. And third one, you should be able to interpret the first Brillouin zone, especially for the SC or the simple cubic, the BCC, the body-centered cubic, and FCC, which is face-centered cubic lattices. So you have SC, BCC, and FCC lattices. And throughout the lecture, keep asking yourself, am I only following the formula, or do I actually understand the physical meaning behind them, behind the concept? Okay, keep on asking yourself. And this topic is originally planned across 2 weeks, but I think we need to squeeze it into 1 week, 1 week only. And in the first part, we will cover the crystal lattice concepts, primitive cells, and diffraction. Then in the second part, we will move to Fourier interpretation, reciprocal lattice vectors, Bragg's planes, and Brillouin zone. And the story today moves in this sequence. You need to understand the real space where the atom located, the real atom is located, and we move to the diffraction pattern of the X-ray, which later we need to learn about reciprocal space. Reciprocal space is a space where the diffracted X-ray converge and predicted how the atom looks like in the real space. And therefore, from the reciprocal space, we will learn how to demonstrate, how to construct the Brillouin zone. So that the Brillouin zone will somehow to get the right picture, almost the right picture of the real space of atom, just like that. That is the concept. Okay. Let's start with the most fundamental concept. The crystal structure comprises of lattice and basis. Lattice is just like your blank mathematical books. We have the squares, and basis is the motif that we should put on the lattices. We should put organize in certain arrangement in the lattices. So a lattice is a periodic array of points in space. On its own, it's just a mathematical framework. So when we attach an atom or group of atoms or molecules to each lattice point, then it will become the basis. And together, the basis and also the lattice they produce the actual crystal structure. So we also know that in 3 dimensions, there are 14 Bravais lattices and grouped into 7 crystal systems. The way we arrange these atoms, we have 14 type of arrangement known as 14 Bravais lattices, and they are grouped into 7 crystal systems. So please remember this clearly. Yeah? The lattice is not the atom themselves. The lattice is the repeating geometric framework. So let us take a look at the next slide, the crystal lattice and lattice plus basis. We will continue in the second video.